guys, welcome to CodeDecode. In this video, we are going to look into some deployment strategies that are commonly employed in the domain of microservices. So in the playlist where we have microservices covered, we have seen a lot. We have seen why microservices, why not monolithic, what are API gateways, what are Eureka, what is Hystrix, how to have the fault tolerance, how to have the applications created in a microservices environment, how do they interact with each other, how are REST APIs used to interact with them, how in asynchronous way, how we can interact with them using Kafkas and all. We have seen a lot. But what the most important thing that we have left in this microservice series is how do we actually deploy these microservices. Just bear in mind that these strategies that I'm going to cover to deploy the microservices are not just limited to microservices but can be extended to multiple applications like native applications, mobile apps, even monoliths. Like for recreate deployments, we usually regenerate them in the normal monolith applications also. So this is not just restricted to these, but these are the 7 strategies which are commonly used in enterprise level applications in the microservice architecture. So let's get started and let's see all of these 7 deployment strategies. So let's start with very common one that we all used to use. Like for example, a recreate deployment where you have a pod which is running with the old version of your application. You are given a task or an enhancement. You add the code in your local, you test it, you do the CI/CD pipeline, you move it to the UAT platform like performance environment. You test it there, everything is fine. Then you deploy the same image or the Docker image to the K8 pods for the prod environment. And for that deployment, how is that deployment done is what these 7 strategies talk about. The first is the very simple one, recreate the deployment. That is, delete the old deployment, create a new deployment, and for sure there is a downtime between the deletion of the old pod and the creation of the new pod. So by the time the pod comes up, your clients will not be served with any request, your application will be down. So this is suitable only for non-critical systems or the place where low traffic periods are there during the downtime. For example, I used to do this in my project where, like for example, a European project. So we used to use a time in the early morning. So that is where you can use the recreate deployment where some downtime is okay because nobody is going to shop in your e-commerce website at the midnight or beyond a particular threshold like at 4 a.m. or 5 a.m. at European time. So that time we have used the recreate deployment, but this is not a recommended approach. Let's first see what this approach involves. This approach involves shutting down the current version of application and deploying a new version of it. And this is simple in a direct method but causes a downtime. This is very important. Why this is that unpopular? Reason being it causes the downtime and gives a user experience break in the service until the new version is up. So as discussed, you get a new enhancement, you create that feature, you fixes, you do all the changes, you add it to your version control system like Git, you do the local testing, you ensure that all the dependencies are fine, you run the CI/CD pipeline, you automate your tests in the CI, you do the BDDs and all those things. Then you create an artifact that is a Docker image or a .jar. Then you add it to your Docker Hub or the JFrog repository as a jar, if there is a jar. Then you deploy it to your pre-prod environment, you do the UAT there. And here comes the actual step. Everything that I have covered till step number 2, that is pre-prod, everything will remain same for all the 7 strategies. What change will come here is from the step number 7 where you actually do the production. So in the recreate deployment, we inform all the stakeholders about the planned downtime. And we will be selecting the time where there is a low traffic period. We do the backup, we do the deployment, and during the deployment we shut all the instances, that is basically kill the pod, deploy the updated application from the artifact either from the Docker Hub or from the JFrog, and restart the application. And once that is updated, it's all fine, all logs are all fine, you're good. In case, now if anything goes wrong, in case this is not working fine, then the downtime will increase. Why? You will go back to your old version and deploy that. So twice you have made the pod down. First you killed the old one, you initiated the new one. Now you're killing the new one, initiating the old one. So here the downtime is double. In the worst case scenario, you are in trouble. This is why this is not much of the feasible solution. So in the recreate deployment, typically we have only one instance of the application running at a given time. Reason being, I'm not saying the replicas are not there. I'm saying replicas are there. But all the replicas goes down at once. All the replicas comes up at once. In the other builds, like for example, during the blue-green deployments, during the canary deployments, it's not going to happen. One of the instances will be up all the time. Here, there will be a case when none of the instances will be up. So usually one is the number of instances. It is said usually. There can be more than one also. The downtime is always there because the old one version is stopped and the new version is brought up. So backup we have to do so that if you want to roll back, we have to have the backup also. So the only use case for this is very simple applications. It is not suitable for the critical applications. It is only suitable for non-critical applications where occasional downtime is acceptable. Now I'll give you a quick overview how this recreate deployment works. You as the developer, you push the code changes to version control. You, after doing all the testing in your local, then you trigger the CI/CD pipeline. You build your artifact, either your Docker image or your .jar or war. You add it to your artifacts to your artifact repository, be it a Docker Hub or the JFrog repository. Then you deploy it to pre-prod environment or the staging environment, perform the UAT. As everything is fine, from this artifact, you do the deployment. Before doing the deployment, you have, after performing the UAT, you give a notification to your stakeholders that there is going to be this much amount of downtime because we are going to kill the old instances, create a new one. But before even doing the production environment release, you are going to have the backup of your prod data. Because they have to have a rollback, you have to use this backup, which is very bad again. If the backup is crashed, you are in trouble. So that is why I never suggest this deployment strategy. Then you deploy the new version. As soon as you deploy the new version to your production environment, you start the application. Also, once you have everything monitored using the monitoring tool, you inform your stakeholders that the deployment is completed. Only after the monitoring tool says everything is up and running and everything is fine. And then you keep on checking your logs and you set up alerts if anything goes wrong. So that is a very simple recreate strategy. Hey guys, recently we have launched a course covering an end-to-end full stack application using Angular as front end and microservices and Spring Boot as the back end. Also, we have used cloud to deploy this application, and we have used CI/CD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is REST-RESTful web services, Spring Boot and microservices for backend, Angular for front end. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka Server and all those microservices counterparts. Now, this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links. Now the second is the rolling deployment. What happens in the rolling deployment is, suppose you have 5 instances of your application. Now you will not take all the 5 instances down at once and start your 5 replicas again. That's not how it's going to happen in the like we used to have it in a recreate deployment. Here, if we have 5 instances, we are just going to update one at a time, place it with the new versioned pod. And similarly, we do it until we have 5 replicas with all the 5 new versions. So what makes sure is that at one point of time only one is unavailable, rest 4 are at least working. Maybe it was with the old version for the first time. For the second time you have 3 old version, 1 new version, and so on. That's how. So in the rolling deployment, a subset of instances are gradually replaced with a new version. This continues until all instances are updated, allowing you for the minimal downtime. For example, in a cluster, you have 5 replicas. Then the system upgrade might have only 1 unavailable instance and maximum surge of 1. First of all, what you see here is a K8 deployment. This might not be that much understandable to you if you have not done the K8 deployment earlier, but this is just a script to do the deployment. So if you can see, this is the kind of deployment for your My application. Reading from here, they would do all the kind of deployments. This is the container specifications. These are the selectors. This is the type of strategy that is being used while deployment. So if you don't understand this, just ignore. Just see how in the K8 we can do the deployment as the rolling deployment. I'll be showing this kind of example in multiple examples below also, like canary deployments, blue-green deployments, but you don't have to worry about all these things because this is very K8 specific. What you need to understand is what actually happens behind the scene. So what happens in the rolling deployment is, if you have 5 replicas, you will just make sure that only 1 replica is taken down, it is replaced with the new one, and the process continues until all your 5 instances are the new version applications. The max search is the one additional pod that is above the desired replica. So desired replicas are 5 replicas. Now here is one up. That means at a point of time, 6 pods can run at a time. That is the maximum pods you can run. So what are the steps used in this? The Kubernetes creates 1 pod with an updated version v2, making it 6 pods at a time. That is how you made sure with max search. With max search, it says you have 5 replicas, but I have max search of 1. So I have 1 extra bandwidth. So what I'll do is, with that 1 extra bandwidth, I'll create a v2 version instance. And as soon as 1 pod is up and running, it terminates 1 old pod. So now you are back to 5 pods. The process continues by taking 1 old pod down, updating the new pod with version v2, and it goes on until an exact 5 pods are there with you with v2 version. Going to the canvas, if you can see here, if you are a developer, here you have repository where you have your code, you have a staging environment, production environment, and monitoring system. So rolling deployment is very simple. What they do is, once you have an acceptance from the developer with the UAT done, what you do is, the next thing you do is, you go to the production environment, you replace 1 old instance with the new one, you do the health check, is that instance up and running, then only you proceed, go for the another one, keep on doing the health check for the new version v2, and then proceed to next instances until you have all the instances already updated to v2. So there can be a case that at one point of time, when your request comes, there will be 2 pods with v1 and 3 pods with v2 version. So that's how you one same request can give you 2 different responses. That is the drawback. The beautiful approach, what I find is the feasible one, is the blue-green deployment. Now what is this blue-green deployment? You understand that at a point of time, you can maintain 2 prod environments. Okay. One is the blue environment, which is the current live environment. Remember, what is the blue environment? That is a live environment. Green environment is the new production environment that will create with the new version. Now the traffic is initially all going to the blue deployment production environment until and unless you make sure that your green is up and stable. If your monitoring is done, if there is no alerts, if you can say that yes, now my v2 is very stable, my green environment is very stable, then you can ask your load balancer that now I'm good. I'm pretty confident that my new version code is working perfectly fine for my clients. Please now redirect all the users to the new version. And the traffic is then switched to the green environment once it is verified as stable. If these issues are detected at the previous step only, then the traffic can easily be reverted back to the blue environment for the quick rollback. So this is how beautifully you can do the rollback here. You don't have to need any backup. You don't have to do anything. You just have to roll back to the previous environment. So that's the beauty of blue-green development. This is used where there is a minimum downtime is required and it is crucial. Now, how do we do that? Remember, this is again a Kubernetes script, but you don't have to think about it. You just understand that there are two environments created: a current production environment, which is called as blue environment, where you have the 3 replicas, but there is an old version, my app version v1. Then you create another version, that is my app v2. So at any point of time, you will have total 6 pods. Even though you have replica as 3, when your deployment is done, you will have 6 pods. 3 pods will be running the old version, 3 pods will be running the new version. And unless you are not very secured and confident, none of the traffic will be going to the green environment. Once you are confident, you can say that now going forward, remove the blue environment and give all the instances to green environment. So this is how you can route the traffic using the load balancer to the blue and green and back to if there is a rollback needed, or else once everything is stable and you see that there is no problem, a day or two, you can delete the blue environment once the green is stable. Now I'll quickly go to the canvas for blue-green deployment process. So you, the developer, going to commit the code to the version control, going to trigger the CI/CD pipeline, going to test it, going to store the artifact, deploy the new build to the staging environment, perform the UAT. Once the UAT feedback is fine, you are going to use the same code from the staging of the pre-prod environment, deploy it to the green environment. Now remember, with this green environment, you have also the blue environment. So at this point of time, the load balancer is going to maintain the traffic till the blue environment only, until you have not done your testing. You don't have the test result. If the test result passes, now the load balancer removes the traffic from here and switch the traffic to green environment. But in case if the load balancer sees that there is an issue and tests are failing, that is going to roll back to the blue environment. And once everything is done and no rollback is required, if monitoring says fine, monitoring feedback is also fine, then you can easily go ahead and decommission the blue environment. So this is how beautiful the blue-green deployment works with the load balancer. A load balancer is an intermediate who is going to maintain the traffic to the blue environment till there is all the testing is not done on your green environment after the deployment. And this makes sure that there is the zero downtime. The only downtime you will feel is the time that is required by load balancer to switch the traffic from blue to green. That's the only place where you will see. So that was about blue-green deployment. The next is the canary deployment. The canary, this is again a beautiful way of deploying, but this is to be done for the small set of users. So canary deployment involves releasing the new version, that is v2, to a small subset of users. For if it performs well, then only to more and more users it is going to be rolled out. So this approach reduces the risk of the impact to the larger user base. So this is done where you have users as a very important criteria. So when there is a very high traffic coming for the application and where the user experiences the utmost priority, that's where you can gradually expose your n number of users slowly and steadily to your new features. Keep on getting their feedbacks. If it is fine, then go whole and full-fledged to whole user base. So that's how you make sure that with the canary deployment, you update only a small percentage of pod with the new version, monitor it, get the feedback, and then gradually keep on increasing the number of pods, keep on getting the feedbacks, and go live in the step-by-step process. Now I'll quickly give you the canary deployment strategy. So here we have 10 replicas. Okay, so you have a my application with the version 1 with the 10 replicas. So if you have 50 requests, initially all the 50 would have been gone to the initial stable version. But then you do one more deployment called as my app canary deployment with version v2. Now with the version v2 in place, you said that only 2 pods will be up and running with the v2. So suppose 12 requests comes, now 10 requests will be handled by this replica, 2 requests will be handled by this particular pod. That's how you will make your load balancer do this. That only a small number of specified user will be given a chance to run the new feature. And if they say that yes, this feature is really good, then you go ahead, increase the replica to 3, 4 and reduce this replica to 9, 8, 7 and so on. So deploy the stable version and a small subset of pod with the canary version. So 10 will be for the stable version, 2 will be the for canary version. Now with the load balancers help, route a very small traffic of user to the canary version, that is a new version. Monitor the performance, have the error rates from the canary pods. If everything goes fine, gradually keeps on increasing the canary pods if no issues are detected, and once the canary is completely verified, gradually shift all the traffic from the old version to the new canary version. So how beautiful is that? Let's see with this AI diagram. So this is the user who is going to access the application. So it gives the request to load balancer. Now it's the task of load balancer to route few of the requests to old version and a very few of them to the canary new version. With the small subset to the deployment, it does the performance metrics. It analyzes the metrics and give the response back. Then the load balancer sees that yes, metrics is satisfactory, we have got a good response, gradually increase the traffic to the new version. So now the new version gets more traffic, and it continue to maintain the new version if everything is fine. But in case there is a rollback needed, if there is some feedback which is wrong, or there is something which crashes or error rate increases, in that case load balancer makes sure that now all the traffic goes to the old version and new version is completely out of the scope for load balancer, and then it continues to maintain the full traffic to the old version only, and hence no rollback needed. Only with the simple shift of the load balancer's traffic from new version to old version will be enough for the rollback. So that is why I say this is the beautiful version. No backup required, no rollback required, nothing. Just the switch is required from old to new and new to old. That too, this is used, canary deployment is used when you have a very high traffic and you want to test your feature with a small number of user base. So that's the canary deployment. Now, this was with few number of users, where few number of users get to have a new feature, rest all users have the old feature access. There is another sixth strategy called as A/B testing. Now in this case, your whole user group is divided into A and B. No new, no old, rather A and B. So there are different group of users who are going to have the access to A functionality. There are different group of users going to have the testing for the B functionality. And then that is becomes the A/B testing. That is the very function specific or feature specific experimentation. So A/B testing is very similar to canary deployment, but typically used for feature experimentation. Not the old or the new, rather A version and the B version of the same application. It serves to the different users simultaneously and see which performs better. If A performs better, going forward, only A feature will be in the picture, B will be discarded. And all the users will be using the A feature. If B performs better and outrolls the A, then all the traffic goes to B and A is completely out of scope. So this is designed for especially UI UX changes or behavioral testing. How this is done? Again, the Kubernetes resources will be used to deploy multiple versions of A and B as a separate service or deployments. Till now, we had one deployment. Here you can see we have two deployments. One deployment having the version A, another deployment having the version V. And the load balancer is the one who is going to split the traffic explicitly with 50-50% each to version A and version B, and you can monitor it. So let me quickly show how A and B works. This is a user group A. This is the user group B. This is the feature A. This is the feature B. And between is the load balancer. Now A user requests a feature. B user requests a feature. Load balancer understands that these many user groups, like these are elite people, I have to give them the very good feature service A. And these are the normal user group. I can try and see if the less number of resources, using less number of resources, will they still be happy with feature B. And that's how they route the traffic between A and B. They get the response from A and they get the response from B. But before that, they will collect the data. The feature A data will be sent to analytics service. Feature B data is sent to analytics service for the feedback. If A version is outperforming B, then the load balancer is going to promote version A. If B is better, then it is going to promote version B going forward. And it is going to be done till there is a no clear winner. A and B testing is continuing till feature A and feature B. As soon as they see that yes, there is a clear winner, that is version A, then the load balancer going to switch to all the users A and B to feature A. If B outperforms, all the users A and B is going to be redirected to feature B, and that's how A and B feature works. The seventh one is the shadow deployment. In the shadow deployment, the new version runs in parallel to the old one. Till now, what we have seen is either you have few users using this, or either few pods are having new and old one. This is the complete different deployment where you have a new deployment, which is a shadow deployment to your old deployment. I find it overdone and over expensive, but might be in some cases this might be used. But let's see what it actually do. In shadow deployment, a new version runs in parallel to the old one, but the new version receives a copy of live traffic without impacting the actual user experience. So what happens? Let's see through the canvas, too much of theory. So user sends a request to your load balancer. Now it's the task of load balancer to first of all forward the request to old version and give the response back quickly, because I don't want the user to be having the bad user experience. But simultaneously, one more task the load balancer do. It do the shadow of traffic field. It sends the request as a duplicate request to new version and ask the new version to process it, and then log the result and see whether the response written from this and this is same. Basically, with the new version, there is no disruption in the old version's functionality, and the new version is also working fine. So that is the task or the logic that can be written on the load balancer. Sometime, like for example, I am pretty confident now that my old version of the previous version resembles my shadow one. That means my shadow one is not breaking my old functionality, or it is still performing really good in the same amount of nanosecond time the response is coming. If I'm perfectly confident, then I can ask the shadow resource, the shadow pod becomes the primary pod, and I can delete the old pod with the new version I have in live and in progress. So it's the task of new version to send the metrics to monitoring system and tell them about how it performs. If the monitoring system says yes, it is performing good, the NFRs are still getting met, that is non-functional requirements are still getting met, the functional requirements are also met, the new version is perfectly fine, then you can ask the DevOps team to delete the old version and continue with the version. That is very simple shadow deployment. And here you have two kinds of deployments. That is version 1 and version 2 deployments. Now the last one is the feature toggle deployment. Now this is very specific and corner cases, rare cases, where there is a new feature included, but that new feature is only and only for few users, and for few users it is disabled. So what you can do is in your properties file, you can enable that this particular set of users will be able to use this feature. For rest of them, this feature will be toggled off. Toggle means true or false. If toggle is true, user is allowed. If toggle is false, user is not allowed to access the new feature. Too much of theory, let's go to canvas. So in the feature toggle, what you do is, as a developer, you create a feature toggle service. In the properties file, you create the user base, that this much user base should be able to access the feature. So if that user has the feature enabled in the application, it will be able to access the new feature and provide a very good new feature experience to that particular user group. If the feature is disabled for my existing user group and the user belongs to that user group, then it provides a very standard experience of the feature. No new feature experience will be given to that particular user. Once you are very satisfied that your premium users are very happy with your new features, you can keep the toggle on going off gradually with your more and more user groups. And at point of time, you can completely remove that from the property and keep that new feature toggle on for all your user base. So for the selected user, you can enable the feature, access the feature, provide the new feature. Once everything is done, you can completely remove the toggle user base property from the properties file and give this toggle feature to all your users. Or if you don't want that, what you can do is you can have the, like for example, you have in the YouTube members only content. So you can have your members only content created here. Only those selected users will have the access to those features. The rest all will have the standard experience. That's how. So that was 7 or 8 ways of actually deploying your microservices In the interviews, we might be not able to tell them what strategy we use to deploy. What we do is we use K8 to deploy, we use Kubernetes service from Azure and AWS to deploy, but we don't actually know the strategy. So these are the strategies which we have to explain them in interviews, like how we actually deploy, maintaining the no downtime for our microservices at the real time. So that was all about this video. Let me know in the comment section if you need more such interviews on the interview questions on the microservices. Thank you.